Welcome physics students. In this video lesson, we're going to learn how to add forces using the Pythagorean Theorem. But before we do that, I first want to review what we learned in the last video lesson. In the last video lesson, I said that often for any given object, there are multiple forces that act on it at the same time. And what we did is we learned some techniques for finding the combined effect, or the net force, or you could say the resultant of the forces as they're acting on one object at the same time. So what I'm going to do is I'm just going to review what we learned in the last lesson first before we move on to today's information. What I'm going to do is pause the video now to give you a chance to copy this down. Okay, as I said, this is a review. So let's suppose you have two forces. One is 45 newtons and the other is 35 newtons. To add those forces, what you do depends on how they're oriented. Let's suppose both the forces act to the east direction. So maybe you've got a box over here and you and your friend are both pulling on this box with these two forces in the same direction. To find the combined effect in this case, you simply add the forces mathematically with a plus sign, and you get 45 plus 35, 80 newtons is the combined effect. What that means is that these two people could stop pulling, and the third person can come along and pull once with 80 newtons, and the object will move in exactly the same fashion as when these two pulled. So it's like the combined net effect. Another technique, what you can do if the forces are in opposite directions, maybe you're pulling this way, your friend's pulling that way, is now because the forces are opposing each other, you subtract them instead of add them, and you get an answer of 10 newtons. Now, of course, we would need directions to fully explain this is just the magnitude. So here we might say 80 newtons east and this 10 newtons west or something like that. Now, the force, the net force of these two forces can be any number between these two values. It can never be 9 or 81 or anything outside that range, but anywhere between 20, 20.5, 79.9, anything between those values. In the way you get those other values is by changing between these two extremes. For example, let's suppose instead of like this, you have the forces almost opposite, but not quite. So we tilt the 35 up like this. The way you find the resultant, according to the techniques that we learned in class or in the last video lesson, is you would draw these to scale, maybe like 4.5 centimeters and 3.5 centimeters, very carefully with a ruler. One technique is you create dotted lines to construct a parallelogram. So see how this is going horizontal, this 45 Newton force. So up here you create a horizontal dotted line. And then see this direction going up maybe like 30 degrees like this. So you make a dotted line 30 degrees over here, parallel to that one. So we got a parallelogram. The resultant force is along the diagonal. So the object would slide along like this, and then we'd measure that, and maybe we get 2 centimeters or 20 newtons, okay? Another technique is called the tip-to-tail or head-to-tail technique. It gives you the same exact answer. Instead of constructing a parallelogram, you draw one force first, and then where that force leaves off, right here, you start drawing the next force in the same original direction. So instead of going here, you draw that diagonal force to the upper right here, the right size, and then the resultant is from the beginning of the arrow to the end of the last arrow. You see the black arrow here, same answer, you get 20 either way. And we can measure this angle with a protractor to get the direction. So, as I said in the last video lesson, I'm going to continue with the parallelogram technique. I only mention this because sometimes the Regents specifically ask you to draw the arrows head to tail or tip to tail. So I'm just mentioning it briefly. All right, and then the other, so 20, you know, between 80 and 10, right? And then, of course, you could get 70 if, like, maybe the 35 goes like this a little bit up in this direction, and then you might get 70. So those are how you add the forces. And then we also looked on Friday at an example of drawing the forces to scale if they're 90 degrees to each other. And then rather than a parallelogram, you draw a rectangle, which is basically a specific kind of parallelogram. So horizontal here, horizontal there. vertical here, and the resultant goes along the diagonal, and you can measure this with a protractor to get the direction. So again, this was the review of what we learned in the last video lesson. So let's move on to today, because as I mentioned in the last lesson, this is very tedious. It's subject to error. If you draw this arrow just a little too long, that's going to give you an answer that's incorrect. Also, pencils, no matter how fine you draw, there's a thickness to the line you're drawing. That adds error. So this is subject to error. Today's technique, we're going to use the Pythagorean Theorem. Which is, because it's all done with calculations, will give you a very accurate and precise answer. So, okay. Okay, so here is the problem we're going to do. Determine F net if F1 is 35 newtons to the east and F1 is 35 east and F2 is 45 to the north. To solve this, what we do is we still draw the forces roughly to scale, but only by eyeballing the scale, because it's not going to depend on the accuracy of your drawing, but still we're going to take these two forces and draw a 45 Newton force to the north, okay, and a 35 Newton force to the east. 35 is less than 45. So what I'm going to do is draw this arrow. If it were 45, I'd draw it the exact same length, but because it's 35, I'm going to draw it just slightly shorter. And you just kind of estimate that. Once again, I'm going to construct a parallelogram, in this case a rectangle. So I'm going to draw a dotted line here, parallel to this bottom arrow, and then parallel to this arrow right here, I'm going to draw a dotted line, which means it's vertical. Where those two meet is where the F net or the resultant ends. So right here, I'm going to draw an arrow. I'm going to label that F net. And then that goes at a certain direction. I'll put a theta here with respect to the east direction. And I'm going to try and find that. Old way, we would have measured it with a ruler. We can't do that today because we sort of eyeballed. What I'm going to do is pause the video here to give you a chance to copy the rest of this down. Okay, let's move on. Make some room. Okay. So to find this net force, you could see we have a right triangle here, a 35 newtons here, and a 45 newtons on this side, because it's the same size over here, rectangle, the two sides here, same size. So I've got 45 on one leg of my triangle and 35 on the other, and this is my hypotenuse. So to find the hypotenuse of a right triangle, as I erase, you could use the Pythagorean Theorem. And again, in Regents, you need to write out a formula before you begin your calculations. Always the formula has to be written first. So I start with c squared equals a squared plus b squared. Now I can plug in the numbers that I have and the variable that I have, f net. So I can say f net squared, that's the hypotenuse, is going to equal the 45 newtons squared, and added to that the 35 newtons squared. Now if you punch that on your calculator and get a result, 45 squared plus 35 squared, you get 3,250 newtons squared. The variable gets squared as well. So how do I find f net? I've got to take the square root of both sides. So taking the square root of 3,250 on my calculator gives me my final answer for the magnitude of the net force, or the size of the net force, as about 57 newtons, I believe it is. Okay. Now, the net force also, as all forces, requires a direction. So we'll find that direction by finding this angle. Now, finding angles from the sides, you're going to be using either sine, cosine, or tangent functions. I'm going to pick the tangent function because tangent is defined as opposite over adjacent. So this is our theta. The opposite side is opposite of the angle, right here, the 45. Adjacent is the side that's next to the angle. And here's our angle, so next to it or adjacent to it is 35 newtons. Knowing those, I'm going to use those then to find theta. But like over here, I got to write out a formula first on the Regents exam. So I can write something like tan theta equals maybe opposite over adjacent. Or you could say tan theta is b over a, something along with the original variables, as long as it's a formula without any numbers in it. Okay? Now I'm going to plug in my numbers with the units. Remember, Regents is very picky. Formula, numbers with units. Opposite side, as I mentioned, is 45 newtons. Now, when you divide that out, the Newton unit actually drops out. But 45 over 35 is approximately 1.29. No unit to that. Now, how do I get theta? What I have to do is do the inverse tan of 1.29. So I could say tan to the minus 1 of 1.29. Oops, sorry. Don't get theta equals. And if I punch that on my calculator, I believe you get about 52 degrees. So There's the magnitude of the net force, and here is the angle of the net force according to the diagram. I'm going to pause the video here to give you a chance to copy this down. Okay, so that is adding forces using the Pythagorean theorem. You draw the forces roughly to scale, okay? And then you construct your parallelogram, or in this case a rectangle, and make the hypotenuse, put the angle here, and then Pythagorean theorem, magnitude of the net force, tan function to get the magnitude of the angle. Okay, so that's it for today. I'll see you in the next physics video.